Yeah, is it visible?
Yes, sir. It is visible.
Okay. Fine, then I start with due permission from all of you. Antarctica is considered, an ideal laboratory for undertaking research in various domains of sciences due to its significant geographical location. It's at the southernmost tip of our globe. Dynamic ice sheet, which keeps on fluctuating, and the impact on the global climate system. The vast ice sheet that covers nearly 98% of the continent hides several interesting geological puzzles that excite our scientists even today. For example, if you see on the right-hand side cartoon, which shows you the thickness or the depth of the ice concealing a lot of the mountains. And if you take a section across from the West Antarctic, going through trans-Antarctic mountain ranges to the East Antarctic, you'll find a thick ice domal cover concealing a very rough topography beneath. And one of the ranges in this, which is concealed, is the Gemdorso subglacial mountains under Dome A in the East Antarctica. And this is very particular, very peculiar also because it shows existence of a fluvial system, prior to the onset of glaciation at the Eocene-Oligocene climate boundary. That's around 34 million years before. Features, characteristics of the glaciation are evident across these mountains, and this we have derived from the aerogeophysical surveys in that area. The question is, many people, as also the media, they keep on asking why we should invest in Antarctic when there are no visible atomic gains. And also, if we do invest, what should be the broad guiding factors for our activities? We should know that Antarctica is a heritage of mankind, and science alone is a currency over there. And then it has got a huge impact on the global climate system. The East Antarctic ice sheet and the West Antarctic ice sheet, there are two portions in which we divide Antarctic through a trans-Antarctic mountain ranges on one side. They have a capacity to rise sea level by 58 meters if melted, and thus most studies focus on this issue and its consequences. That means if the Antarctic ice sheet melts, in total what happens to the mankind, what happens to the streets which cover all the coastal parts of the world. There's a very famous glaciologist working in the United Kingdom with the name of Sigurd. In 2023, he gave a statement saying, we don't discount at all that the East Antarctic can start releasing mass into the ocean within this century. So this is a short-lived of the future goals. Whatever it is there, we have to be clear in our mind that Antarctic has got a both strategic and the scientific importance, and our goals should be given to the future, not in the immediate past. Even if the Antarctic ice sheet doesn't contribute much to the entire sea level rise at present, but what will happen in a couple of centuries afterwards, we do not know, and the chances are that it will have a grave impact on the sea level rise. Well, there is another point that since no country has sovereign authority over Antarctica, so how do we do the science there? Who governs the science? Who governs the territory? And who sees that which Antarctic station should be there? There's a non-governmental body formed by nearly 50 nations. It's called SCA, Scientific Committee on Antarctic Research. And it is this body that coordinates and defines the global agenda. It advises the Antarctic Treaty Committees. And when I say Antarctic Treaty Committee, this is a governing body that takes care of all the Antarctic matters. As I said, there are no governments in Antarctic. So this ATCM looks after all the governing factors of the Antarctica. And all the scientific issues that are raised in those meetings are guided by or advised by SCAR only. Now, SCAR operates through its working groups, which are defined as physical group, biological group, geoscience group, and another group on humanities and social science groups to take science forward. We are concerned here with the geoscience program because it forms the cornerstone of Antarctic or the polar science. And the SCAR has got a huge involvement of India. India is a very major player. It has two vice presidents in a short span of about 40 years. And apart from that, we have had two chief executive officers who are looking after the geoscience group. Even currently, Professor Pant, N.C. Pant of Delhi University, is holding a position of the chief executive officer of the geoscience group. So coming to the India in Antarctica, if you go through the span of the expedition history, right from 1981, when we started our first expedition till now, India has been active in Antarctic research with 42 scientific expeditions to the Eastern Antarctic taken so far, one expedition each to the Red Sea and to the South Pole, and 11 expeditions to Southern Ocean. Indian scientists have practically been to all the corners of the Antarctic, as you can see from this slide, all radiating from the center of the Antarctic, and we have not left any corner excepting maybe some part of the Western Antarctic. And this has helped India, to establish it as a key player in the global scientific community, earning India a prestigious position in the Antarctic Treaty Committees, the SCAR, and the COMNAP, which is a platform for national Antarctic programs. These are the three international bodies responsible for governance, science, and logistic cooperation in Antarctic. So if I concentrate on this slide, in 1981, we went to Antarctic and landed in 82, and the first station came up in Dakshin Gangotri and returned from 83 to 88. Subsequently, we selected an ice-free area in the Schumacher Oasis, which is located in this area, Donning-Moreland area, and this station was constructed in 87. It is still going on there. Even after 35 years or so. In 2002, we started another area in Princess Elizabeth Land, and currently most of the geological activities are concentrated on this area. In 2012 onwards, we selected this last one is area where we had another station, Bharti, which you can see over here. This was established in 2012. And since then, regular expeditions are going on there. We have a station there called Bharti. We also had one expedition to Wilkes Land in 2018, one in the South Pole in 2010. We had also visited in the Red Sea area, one of such expedition led by Dr. Rana and participants like Dr. Mukherjee and others. And then we had also one reconnaissance expedition or survey in the Antarctic Peninsula when we sent some of our officers to Brazilian stations over the Antarctic Peninsula. So we have practically covered all parts of the Antarctic and gained a lot of knowledge, which stands to our benefit at present. Coming to the science, Antarctic science, we have had a very good say in the Antarctic sciences. Most of the papers are, as you know, are being published in the atmospheric sciences, oceanography, but Earth sciences has not been left behind. According to the National Science Foundation's Science and Engineering 2022 report of the US, India's position globally in the scientific publication has improved from 7th position in 2010 to 3rd position in 2020. And we have got publications in all the leading journals, starting from Nature to 3P and all others, geophysical research letters and others. And after every 10 years gap, they are also making a point to publish structural souvenirs or volumes on what we have been doing in Antarctica, whether it is basically our sciences, as you can see here, 3 decades in polar sciences, and a proceeding of the National Science Academy, which came in 2017, then a journal on polar science, which came very recently in 2020, then 2 volumes which came up with the SCAR collaboration. Then we had some on biology, we had one on the atmospheric sciences, then current science published one and one on the physiology. So we have covered not only our science, we have covered many other sciences also. But for the present talk, since the subject is too vast, and if you want to do justice only to inform you what we are doing in the geoscience, we will just touch upon the thematic subjects. I can't go in much detail, but I'll try to focus on all the major themes, major projects that have been undertaken right from the beginning till today, and even some of the projects which are going to be taken in the next 43rd Indian expeditions to Antarctica. The geological exploration in the central Donning-Moreland, this is a major area, which has been taking a lot of attention from India. This northern part is called as Donning-Moreland, and Schumacher is also the northern part in the coastal area, and Dakshin Gangotri would be somewhere here. So Donning-Moreland with Schumacher at its northernmost rock exposure forms part of the coastal mountain chain of the East Antarctic. And in 2 stations, we had one Dakshin Gangotri station in here in the shelf area, and then one in the Maitri, which was on the ice free area. This is Maitri, this is Dakshin Gangotri, and from these two areas as the base stations, we covered huge distances all around wherever we could go, either on foot or with helicopters. And as you know, the range of the helicopter is limited up to 200 nautical miles or so. So we covered the area right between 15 degrees longitude here and up to 2 degrees longitude over here. And southwards, we covered the entire range of Volsat mountains, and whichever mountains we came across up to 72 degrees latitude, we covered it. And you know, these bases, what we have been doing is, as the main science theme was the elucidation of lithostratigraphy, structure, tectonics, metamorphic history of the drowning moorland. And right from third excursion onwards, this exercise was going on, and it is still continuing. The only difference is that from the systematic geological mapping, we have shifted to thematic mapping and taken up the special themes for our understanding the geoscience problems. An area of nearly 20,000 square kilometers has been covered in these areas, and the geological maps have already been published and circulated. These give you some small glimpses of the Shimakar, because this is the main area where Indians have been working, because their Maitri station is located over here. So because of the accessibility, close accessibility, everybody gets a chance to look at these hill ranges and map and contribute whatever he can do. The geology, deformation and metamorphic history of the rocks exposed in Shimakar has been worked out in great details by several workers, including Sudipta Sengupta, R.K. Singh, Kaul, Ravikant, Bose, Hazra, and several others. The rock types exposed are shown in the map presented, and you can see over here all these rocks, for example, metapelites, quartzofeldspathtic gneisses, garnet-rich biotite quartzofeldspathik gneisses, and some of the intrusives like norite, enclaves of metamorphics and gyranocrites and others. They're all present over there. The earliest granite facies metamorphism took place at 750 degrees to 800 degrees Celsius under the 8 kilobar pressure, followed by an isothermal compression at 750 degrees temperature. And then again an isobaric cooling at 5 to 6 kilobar pressure is recognized. A later retrogressive phase has also been widely recognized, and some workers like Ravikant, they have provided SMND data for most of these metamorphic events that have helped in correlating the Shimakar as part of the East African origin. Now we come to the main mountain range of the central drowning moorland, and this is a coastal mountain chain which is called as drowning moorland, and we are referring here only to the central part of the drowning moorland. There are ranges on the east like Luzo Basin and others. We are Japanese have the stations, and further on this side we are Norwegians have a station, and then gradually we come across the trans-Antarctic mountain ranges over here. The coastal mountain chain of drowning moorland exposes from east to west. The Gruber mountain chain, Gruber mountains over here. And the Petermans, which has got three ranges. Peterman, we call them as Peterman 1, Peterman 2, Peterman 3. And then we have got Orvin mountains, and then Muling Hoffman, and then there's Fella. Fella is the Norwegian term for mountains. So all these are exposed in this drowning moorland. The rock types exposed are predominantly Visonioprotozoic, high-grade granolites to amphibolic facies, paragneiss, calcgneiss, orthogneisses, anorthosites, and these anorthosites are basically present in the Gruber. And then foliated gyanocytes, magmatic suits, alkali granites, and with rafts of country rocks, late intrusives, dolomites, lamprofire, and norites. As you can also see over here that some of these areas which have been mapped, their maps have been published. You can see over here three main geological maps which have been published on 1:50,000 scale and also distributed for wide circulation to the scar. And this is a map of the Shimakar oasis. This is a map for the Muling Hoffman, and this is the one for the Orvin mountain range. Some details about the Volsat mountain, because Volsat mountain is the main mountain range where a lot of interesting data has come forward. And this mountain chain, it comprises of Gruber, Peterman, Zuisel, Peer, and Humboldt mountain. And while the Gruber in the east, over here, This exposes a massive type of anorthosite and outer zone of norite as intrusive into the late Mesoproterozoic, orthogneisses and other supracrustal rocks. The Peterman Ranges and Jussel Mountains, located west of the Gruber Mountains, they occur as three ranges, parallel ranges, as I was telling you, Peterman 1, 2, and 3, and they expose a lot of para and orthogneisses and also some Chernobite suits and also sites in the fringes of these hill ranges. We have got some granite dating also has been done. Williams strontium isotone date of 514 plus minus 15 from the Humboldt, and then Mullinghoffman has given granites from Mullinghoffman have given the age of 750 plus minus 61, and some ranges further east of this area, further west of this area by Japanese and Norwegians, they have given the age of 500 plus minus 24 million years. The event at 640 million years granulates of the Humboldt have been considered representing the extension of the East African horizon, and this is basically worked out by Pant and his team, which is published also. There are some more geological dates which have been worked out in subsequent years from Gruber, as you can see, is 587 million years dates. And then we have got the dates from Orwin and also dates from Mullinghoffman. And these dates are quite old. They are from the orthogneisses, which are presently present there, apart from the intrusives which have been dated at 500 and something, which I told you from the Ogata group. Let us think about this East African horizon that passes through the Schumacher area and some part of the central Drowning Moorland. Based on the similarities of the granulites, representing 660 million years to 600 million years to those of the Schumacher, and a general consensus about the clockwise pressure, temperature, and time paths and the timing of the peak metamorphism, the East African horizon has been extended to the Antarctica. So this is basically the East African origin imprints that you can find extending from the Mozambique sites and entering into the inner part of the Drowning Moorland through the your Mozambique belt and also through the Schumacher and the Drowning Moorland. The southern extension of the East African horizon into the Drowning Moorland can be traced through north-northwest, south-east standing rocks of the Schumacher and Volta mountains, and Nunataks, which are very close, lying in between the Schumacher and the Volta. And these works have been done, basically, I'm quoting from Ravikant and Pant, who have done this work. Now, there's a very interesting compilation that has been done by the SCAR. As I told you, SCAR is an international body, and they look after the scientific things. So they try to, under the geoscience group, they try to collect the data of all the surface geological maps which was available throughout the nations who were mapped, whether it is Norwegian or UK, the group from the Scottish Polar Research Institute, India, and China and others. So nearly 500 geological maps containing the information of the surface geology, they were compiled, put together to bring out a geomap compilation, which is called as GeoMap under the GeoMap Action Group, and this publication has just now been released under the Nature Scientific Data, and the link is provided over here. What you will see in this slide is also the variation of the people, those who represent practically all parts of the world, including India. Dr. Pant is here there. He is the Chief Executive Officer, Deputy Chief Executive Officer of the Geoscience Group, and the Indian flag proudly sits in this compilation. So our map and our work gets recognized in all these areas. It was being felt, that the geological information that we are having from one location of the Schumacher, it may not be suffice to take the wide-ranging continent, because the huge continent of 12 million square kilometer, we cannot have all the information by sitting at one place in the northernmost tip. So in 2003, an exercise was done to select an adjoining area, wherefrom we could get some more data, additional data that could supplement our exercise on, and also finding the links between the East Antarctic and the Indian side of the continent. So we went through all the part of the Antarctic. A cruise was taken, and then finally we selected an area in the eastern side of the Antarctic called very close to the Pitts Bay. This is the site. Our method is located over here, so you can get an idea that this new site is about 3,000 kilometers away from our earlier site. And the two criteria were basically in our mind. Number one was, of course, the geological criteria, geological parameters. We wanted to have an area with which we could correlate the link, India and Antarctica Gondwana link from this area. And then the logistic part was there. We wanted an area where our ships could directly land into the station without passing through a tedious shelf. For example, in the Maitri area, we had to crisscross about 100 kilometers of the ice, frozen ice, shelf ice, to reach to the station, which involves a lot of logistic effort. But here in this site, you can see that our ships can come directly to the station and they can be berthed right alongside the station. So all the logistic exercise becomes very easy. You can walk down from the ship to the station, conduct your exercise, your project, and then go back to the ship. Now this site was selected, and unfortunately I was in part of that team. And then the station was constructed in 2012, and now it's running perfectly well. So all automatic station, and it's considered one of the best station in the Antarctic. So this eastern sector that we are talking about now is quite different from the northern sector or our Shimaka sector. I mean, because if you see from here, this sector lies in between this stretch, this arc of the eastern Antarctic, which you can extend from the Davis station of the Australia, extending to the Indian station over here, Bharti, Larsen Hills, and then further going to the Emery Ice Shelf, and then some of the mountains over here. And this is the Princess Elizabeth land that we are talking about, this Princess Elizabeth land, PEL land we are talking about. And this is the Emery Ice Shelf. Here we are talking about this Emery Ice Shelf over here. And all the mountain ranges which are adjoining this area, this falls now in our domain. Now this is a picture of the Lambert Glacier, which is one of the fastest moving glacier of the world. You can see over here, the different rates are there, and very several kilometers per year is the movement of this glacier, and it diverts in the Pitts Bay, giving rise to a huge pile of the sediments. Under a multi-institutional coordinated project, which is called as Geological Exploration of Emery Shelf, geologists from several institutes of India, like Geological Survey of India, National Center for Polar and Ocean Research, Delhi University, Banaras Hindu University, IIT Bombay, SAC, and others, they are currently investigating this area. And this domain is considered crucial, not only because of the link with India and Antarctica, but also because of the presence of the Archean proterozoic terrain, as also some of the Gondwana sediments, which have got a great bearing. Now, these terms you can see here, because we will keep on referring to these terms, like Princess Elizabeth Land over here, then the Pitts Bay over here, and of course you have already heard about Drowning Moor Land, and this Wilkes Land over here. Now, this is basically a subglacial map of drainage, which has been prepared through the geophysical surveys. And a total intensity magnetic and the satellite-free gravity data inferred that the shape of the 2,000-meter isobath over the northeastern continental margin of India closely resembles that of the 2,000-meter isobath of the Lambert Graben of the East Antarctica. And we told you the Lambert Graben is here, approximately here, and it is in line with the Mahanadi Graben of our eastern India. Supporting the hypothesis that the eastern continental margin of India and the East Antarctic are closely aligned in the pre-breakup tectonic setting of the eastern Gondwana land. The area was investigated by using geophysical surveys, including radar sounding, laser altimetry, gravity, and magnetic, under an international collaborative exploration of the Central East Antarctic through year one geophysical profiling, and Delhi University was keenly involved in this, as also the NCOR. The studies have also shown that the Princess Elizabeth Land hosts an assortment of the previously unidentified subglacial lakes and presence of a 1,100 kilometer long system of canyons. Now you can see this drainage, and this is very, very interesting, because this sort of the drainage, ultimately gives you some idea about what sorts of these sediments must have been brought from the internal drainage and then deposited in the shelf area, which is on the coastal sides. So one of the IODP's site, which is located over here and further south, the sediments have been taken from there, and a very good idea what the provenance has been obtained, and we'll come to that subsequently. Let us concentrate on this eastern sector because we have been devoting not nearly 10 to 15 years time in this particular area, starting from the West Foothills, Roar Group and all these areas. One-line description of these will suffice. The rocks in the Princess Elizabeth land comprise highly deformed granodites. In the coastal fringes of this land, the major outcrops in the east is of the Arkan West Foothills, which is over here. And this is the area where we have the devastation of the Australia. Further 70 kilometers west in this area over here, Black Silt Land Buff, the Larson Hills and the Bollingen Islands. Here we find mid-Proterozoic block, which is reported to have preserved Greenmanian, that is around 1100 million years, and Pan-African, that is 500 million years, signatures signifying two important amalgamation events forming the Rodinia and the Gondwana respectively. Further 140 kilometers we have got another area of interest that is called Landing Bluff over here, and this has got undeformed granites on the Pan-African edges. The Nunataks and the mountain range exposed along the eastern flank of the Emery Ice Shelf are considered as the Renar terrain over here, this terrain. Now, as we see in the subsequent slide, all this geology matches very well with our own Eastern Ghat mobile belt. In the last one hills, where we have devoted a lot of time, detailed geological mapping coupled with the laboratory studies carried out by GSI in different parts of these areas has revealed that the meta-sedimentary and the meta-basic rock cremates occur as a relic basement within the garniferous gneiss, isogenics, rocks such as garnet, silvinite, cordite, biotite gneisses, garnetiferous gneisses, cordierite gneiss, biotite gneiss, borosilicate gneiss, and variety of other quartzites are present there. These have been mapped. Mineral composition of granite gneisses varies from granite to grandarite, and a PTT path has been worked out. The tectonometamorphic evolution path was considered through the deformation history, and reaction textures have been populated and papers have been written. For example, Sadiq 202, and all these inputs have been given by the GSI team. Interestingly, in the pits where we also have some sediments which are still the Gondwana sediments. We can see over here. It will help us in the establishing a paleo configuration of the Lambert, Mahanadi, Godavari Graben, because these coal seams are exposed and these sediments are also exposed. So the teams from GSI and the GOS group, they are planning for the multi-element studies and the lead isotope characterization of the coal from this group, so that the pinpoint location and the amalgamation and the linkages between the Mahanadi or Godavari basin and the Pits Bay area can be established. This is the summary of the details work done by all the workers like Savil Gupta, Pant, Arora, and others. And I will read these three bullets, and which says that the Renner complex of the East Antarctica, which is over here, and the Eastern Ghat province over here of India are thought to have been contiguous in past supercontinents like Rodinia and Gondwana. These terrains have been correlated on the basis of similar granite facies metamorphic imprints and isotopic age data that testify to 1100 million event, and also the 650 to 450 million years event, that is a Pan-African event. The Greenmanian granite facies metamorphic event is generally thought to represent collision between Antarctic and the Cratonic India, but the precise location of the Indo-Antarctic suture is still not confirmed. The intensity of the Pan-African geological imprints is also variable in both continents, and their significance remains still not very well established. Another view wherein you can see the Antarctic vice versa the Indian position over here, the Australians, linkages with the Wilkie land, and the Rod group and the Renar area with the East India belt of Eastern India, the Dirty Rod land with your linkages with your African origin over here. Further, as I was telling you, we also have been to the Wilkie's land over here, the extreme southeastern part over here. And this area, was not directly investigated. There was an IODP site, which is U1359, under the IODP expedition 318. So sediments samples were obtained from this site by Delhi University workers, and then they tried to work out the prominence because a huge set of rocks, starting from pericavarian terrains and others are supposed to be exposed, covered by the ice sheet, and they took out these samples and tried to work out the prominence. As you can see over here, these are the different factors. These are the mineral assemblages and the rock types, and then the prominence is worked out from this thing. So this was an indirect way of finding out what must be the rough rock type or the lithofacies variation covered on the subglacial in very close to the under the dome aid land in the eastern Antarctic. Now we shift to some of the geomorphological investigations, because geomorphology has been a major part of our investigations. And as you can see, there are three basic physiographic units: the ice sheet, the structural hills, and the ice shelf. Now, if you drill over here, you will go to the basement. 3 kilometers or 4 kilometers if you drill, you will reach the basement over here. This is exposed, and then you have got an ice shelf below which there is a sea. Schumacher is located over here. Over here you can see. And this was a geomorphological map that we have published on the Schumacher geology. If you compile the aerial photographs of the Schumacher oasis, you will see this physiographic contrast very clearly. You got a highly crevassed terrain on one side. You have got a ice shelf which doesn't have much reflections, much disturbances. But then you can find that the drainage from the structural hills is disturbing the shelf, and it is flowing into the ice shelf. And then the very conspicuously, you can find the structural control of the lineaments over this Schumacher oasis is very pronounced. For example, the north-southeast, south-southwest trending lineaments, you can see over here. And most of these lakes, they follow these lineaments, all these, and these have got the subsurface elongations also. Most interestingly, you can find an 8-kilometer long lineament which is running and cutting all the different features, whether it is ice shelf, it is a rocky part, or it is a continental ice. All through it is running, and it has disrupted or cut the structural hills and also affected the shelf. That means it has got some, it is still active, and it has got some new tectonic movements which is disrupting this shelf ice over here. Some of the conspicuous geomorphic landforms, the Rocher Mountain, which is formed by the glacial movements. You can see glacial moving here and then removing a lot of chunks from these sides. There are pattern grounds which are formed on a very shallow slope areas. Then the natural, grinding or sieving of the sediments. Here you have coarser sediments, boulders on one side, and the finer sediments in the center. So these all are called the pattern ground. Then you have got the morainal deposits of the ice sheet, which is coming from the south and leaving parts of these terraces, and through which you can find out the edges of the glacial recession. This is a fossil glacial valley, clearly indicating the path of a glacier, which must have been flowing on this terrain. And this is the ice sheet, so you can link up the ice sheet on this glacier. These are some of the meltwater lakes, as you can see. There are 103 meltwater lakes in Schumacher, huge set of lakes, and I'll tell you about these different genetic aspects of these lakes. Suffice is to say here that this is a part of the drowning moorland. This is the ice sheet, and this is Schumacher, and this is the shelving. The glacial landforms are more interesting. You can see the movement of the glacier has left some scars, grooves over here, and these have been mapped, counted and plotted to find out the movement of the glaciers. And this is the lake, different levels of the lakes, it tells you of different ages wherein the glacial level the lake level has gone down, but the sediments which it has left have been derived from the ice sediment cores, and they have been dated, and very good information on is available from the sediment cores. This is a repetition of the slide. This is again a glacial movement. It has left some of the boulders which it was carrying in its belly over here. This is one of the glacial lake occupying the path of a fossil glacier. This is same as this. You can see the lot of moraines left by the glaciers, and these are the terraces, different levels of the terraces which are present in the Schumacher oasis. A lot of people have been working for the last so many years, among them Asana, Beg, Shivaso, Fatyal, Yogesh, and a lot of people are there I've compiled this information from most of the people, so it's not possible to list everybody. But I acknowledge the contribution of all the people who have been contributing to the science in Shimakar, in Drawing Wonderland, in Princess Elizabeth Land over the last 42 years or so. Special mention should be made of the work of the Yogesh and his group, which has painstakingly taken 276 glacial stations from 20 different locations all over here, plotted them, and find out there's a very path of the glacial movements in the past. You can see that most of the glacial movement has been in this direction. Most are in the unidirectional, but of course some variations are there, local variations are there, which might be because of the edges of the ridges, Shimakar ridges. So deglacial glaciation history, if you find out, the ice retreat here comprised thinning of the East Antarctica ice sheet by about 500 meters in the inner area, and the recession of the ice walls was in kilometers. By the OSL and the TL dating, recession moraine have been dated. Three phases of the moraine deposition during 158 to 125,000 years, 76 to 15, and 22,000 years to present has been inferred. And this paper has been published very recently by Roy, Sandeep Roy and others in the proceedings of the Science Academy. It has been suggested that decreased sea surface temperature and the increased sea ice cover of the surrounding oceans limited the moisture supply, and that led to the retreat of the ice. Between 35 to 40,000 years, since these years, the Himachal oasis has been ice-free. So what all features we are getting is now is basically representing 35,000 to 40,000 years before. Coming to the Larsen Hill area in the eastern side, the lake morphology, the lake chemistry is entirely different because of the closeness to the marine areas, to the sea over here. And most of these lakes which you find in the different peninsula, whether it is Brooklyn Peninsula, the Fisher Island, or the Grones Island of the Bharti Station, all these are having the marine influence. The mixing of the water from the glacier and from the marine is there. And this area is expected to be ice-free since long, more than 50,000 years or so. So they are naturally, that brine nature of the, or the saltish nature, saline nature of the lake can be responsible for that reason, because of the long time of exposure to the environment and to the mixing of the traces from the marine influence. I still have some time, I think, 15 minutes.
Yes, sir. Please go ahead. No problem.
Okay, let us shift to the paleoclimate now, the data that we have obtained from the ice core drilling. Now, ice core drilling formulates a very important part of the Antarctic program of India. We started way back with the GSI taking up the drilling. They, in fact, the glaciologists from GSI with Arvind Chaturvedi and group, they took the lead, but then subsequently NCR built up an ice core laboratory, as you can see over here, and they started taking up the drilling in the several positions. And the main thing of the Indian drilling program is that we don't have the shelters for the ice core drilling, and you can see that we have taken the shelter of a container, and because the winds are blowing at a very great speed, so we take the shelter of the container over here, put our drilling mast in these areas, and they'll do drilling. We have gone up to around 150 meters or so, giving us some idea about the past climate through the oxygen isotope and the hydrogen isotopes. So this is the result of one of the two ice cores which have been taken from the Drawing Wonderland. Ultra high resolution data for the past 100 years, 1905 to 2005 has been calculated, and 470 years from the different core, which was 1530 to 2002. The calculated surface air temperature using stable oxygen and the hydrogen isotope proxy shows that the ice cores showed a warming by 0.06 to 0.1 degrees Celsius per decade, and greatly enhanced warming has been recorded in the past several decades, that is 0.4 degrees Celsius per decade. And most of this data from the ice core is also being contributed to the IPCC reports through our institute in the Pune-based institute, the Center for Tropical Meteorology, which is located in Pune. The ice sheet dynamics is another part, because as you know, 98% of the Antarctic is covered by the ice sheet. So it is not natural that we try to find out how this ice sheet is behaving, how it is moving, and what is the total surface mass balance, whether it is positive, it is negative, and at what rate it is moving. The Antarctic ice sheet has existed for about 35 to 40 million years. since the mid-tertiary, and it is widely believed that in East Antarctic, it reached continental proportions latest by Eocene and early Oligocene. So this is the configuration of the running model, and these are the two shelf areas. I'll go into detail some of these because we have done a major international collaboration on these two ice rises over here. And then JSI has done a lot of studies on this polar ice sheet, and we will, in subsequent 2 or 3 slides, we'll just have a glimpse of that. Since beginning 1985 onward, GSI has been monitoring this tongue of a glacier ice sheet. We call it Dakshin Gangutse Glacier. It is located in Shimaka Oasis, and this is a close-up of this. We have been monitoring this ridge and also the limb over here. And it has been found out that the DG Glacier, Dakshin Gangutse Glacier as we call it, has receded about 42.91, roughly 43 meters in the last 25 years. That is at the rate of 17.16 per decade. So it's a huge recession that this glacier is gradually receding, and this is a pro-glacial lake formed in front of this. Now, the ridges south of the ice ridge, or the ice sheet south of Shimaka over here. Now, this is also in constant movement. And it is only because of this movement, and it appears to be stopped over here. But you can imagine about 30,000 years or 40,000 years before, this entire ice sheet was covering this entire area, and it was debouching over here. That is why you get the very sharp escarpments all along the northern margin of the Shimaka. So we also wanted to know what is the speed or movement and direction of this ice sheet. So IIG scientists, they installed a GPS campaign over here. And then these are the locations of that GPS monitors. And you can find out that two bimodal speed was found out by this GPS campaign. And the horizontal velocity was in the range of 1.89 to 10.88 meters per year. And this is published in the Journal of Glaciology. The speed definitely was more over here because there was no obstacle over here. But since here the Shimaka and some lunatics over here, they created an obstacle impediment, so this speed was slightly less. So on average, it was around 5 to 6 meters per year. Now the ice surface velocities in the area south of this Shimaka, this is the Shimaka Oasis, and we have got the ice sheet all around till we reach the Drowning Mountain or the Olfat Mountains. This is a huge ice sheet which is here. Look at it over here. See, and if we have to understand and quantify the dynamic properties of the ice sheet, such as albedo, solid precipitation, ice mass, movement, and the ice elevation changes are critical for improved climate and mass balance studies. Both the satellite-derived velocities and the model-derived surface mass balance were used to estimate the net ice influx between 2016 and 2020. And part of this exercise was also done by Dehradun-based Institute of the ISRO, Institute of I don't remember the name right now. It's Indian Institute of Remote Sensing, yes. Verification with the help of the ground observation collected during the Indian scientific expedition to Antarctic was conducted during 2016-17 and 18-19, and it is still continuing. And this was the area which was investigated over here. So this is the ice sheet. These are some of the glaciers, Smoking Glacier and the Humboldt Glacier, which contribute to the polar ice sheet. So the area, that's why we selected this terrain, or the GSI and the remote sensing people, they selected this terrain where the direct influence of these streams would not be there. So now this is the division that they did. They called this is impeded polar ice sheet, IPIS, and this was called as high polar ice sheet. So the rate of movement of these two would be different. That is why this was differentiated. The ice sheets of the Shimaka was divided into two parts, as I said, the HPIS, high polar ice sheet, and the impeded polar ice sheet. The 2D horizontal ice stream velocities were measured using combination of ground and satellite-based observations. And 187 ground stakes, they were installed both in the IPS area and also in this the main part of the ice sheet over here. And the recording was done in 4 different field seasons, starting from 2016 onwards, and it continued up to 2020. And the net result was that they have concluded was that the ice sheet flow rate for the higher polar ice sheet varied widely with an average velocity of nearly 20 meters per year during 2019. And for the embedded polar ice sheet, the ice flow rate varied from nearly 1.5 meters per year to 9.6 meters per year, with an average 4.96 meters during 2019. Taking into account the influx and the outflux, the Sumokan ice stream, this was one of the glaciers I showed you in the previous slide, gives a positive net mass balance of 2.35 to 3.15 gigaton per year, whereas it comes to zero, net zero or negative mass balance ranging from 0.0018 or we can say minus 0.26 gigaton per year for the western ice stream. Now the northern part of this ice sheet, I was telling you, the ice shelf area. This is very interesting part because there are certain ice rises which are part of the ice sheet, which are now found frozen and grounded. These particular things, these are five such areas over here you can see, and these is the Anderson ice shelf, and there is another ice shelf over here. So these ice rises, they were investigated by a joint project between the Norway and India, and it was termed as mass balance dynamic and the climate of the central drowning moorland. Acronym was MAD ice, moorland ice. And all this investigation, it involved a lot many parameters like ground penetrating radar, the drilling, satellite observations, and everything. Two ice scores were raised, one for 122 meters, another for 50.7 meters, third for 153.1 meters. Three borrows on these grounded ice rises were taken. The project investigated the ice dynamics, the current mass balance, a study of the past changes in the atmospheric and the sea ice dynamics in these regions. And what were the two findings? The findings were the ice shelf from front facing the ocean may melt from the base in the future as the sea ice cover diminishes. And second was the snowfall rates have significantly reduced since the 1980s. That is from the meteorological plus the ground station data. These are the results of the GPR survey. As you can see, this is the basement over here, and these are the domal structures of the ice rises. And these are part of the ice sheet, as I was telling you. It has moved and it has left the part of these ice rises within the ice shelf. Grounded, we call them grounded ice rises. The study has already provided first estimate of the ice flow, the basal melting of an ice shelf and surface mass balance changes over the ice rise and ice shelf during the last several decades, and then that is through the ice core. Estimates show that until 2010, 3 out of the 5 ice rises were thickening, while 2 were close to the balance. And this paper has been published by Goel et al. And the current director of the NCO, Dr. Thamban, is the lead author of this project of more ice. Geophysical studies, they also constitute a major part of the science studies, and I will quickly go through. The gravity, magnetic and GPS studies formed an integral part of the expedition right from the beginning. These were useful in finding out the structural features, plate motions and crystal deformation of the continent. A 95 9-kilometer magnetic traverse was taken between Schumacher and the Bull Head. And helicopter-borne magnetic and helicopter-supported gravity surveys were taken, and which have led that there is 3.5 kilometers ice thickness is there in south of Schumacher. The Moho thickness has been found to vary from 38 kilometers below the Humboldt Mountains and 32 kilometers below the Schumacher, reflecting the gradual reduction of the crustal thickness from the continental margin below the Wolfsburg towards the deep ocean. The magnetometer, flux gate magnetometer observations are being taken, and this has got a very significant results. The intermittent recording of the absolute values of the total magnetic field by a proton precision magnetometer (ppm) and the comparison of the results with the data of the ppm and the flux gate magnetometer have shown a rapidly declining magnetic field over the past 75 years at Maitri and other southern hemisphere stations. So this is very important observation, and Maitri observatory forms a part of the international group of observation stations. So this is very important. The magnetic flux at Maitri has been reported to decline to 60 per nanotexa per year from 120 during 1995-96, and this is the work of the Pathan. Coming to to the last few slides, I'd like to show you how the international linkages are there with the national linkages. And the SCAR as being one of the major, body which linkages the international science with all through the world. The Indian Scientific Expedition to Antarctic, the SCAR, the Open Science Congress, the COMNEP, all these meetings have been held in NCR. And as I said earlier, 2 vice presidents and the chief officers are from India. And these are some of the science, geoscience group programs that SCAR has got in its offering. That is the ICE-PRO. The Rahul Mohan of the National Center for Antarctic and Ocean Research is there. It's called International Collaboration for Paleoclimate Research. Antarctic Architecture, Dr. Pan, Thaman, and Rahul of India are there. RINGS is another international program, action group of 14 nations for collecting comprehensive bedrock topography data, measuring ice thickness using satellite, especially at the coastal margins, altimetry using GPR and satellite imagery. So and we are also part of the RINGS, and we are also part of the group which is called as Connecting Geophysics with Geology. So these are special projects which have been taken by the Indian Antarctic Program. For example, WAD ICE, it has got direct linkages with this program. GEOS, the geological exploration of the Emery Ice Shelf, again it has got a direct linkages with this paleoclimate and also with the internal structure of the ice sheet. And this is basically a sea ice linked program. In 2014, the SCAR conducted a SCAR Horizon, it's called. They called the representatives from all the SCAR nations to a brainstorming session and asked them to identify themes. So some 80 themes were selected, and then gradually they were shortlisted themes. They were shortlisted further to about 6 themes, and then a paper was presented in both in the Nature and in the Science. India was part of that, and most of the scientific programs, they are following these SCAR Horizon themes currently also. India also hosted the 10th SCAR Open Science Conference, the business meeting of the SCAR delegate meeting in 2002. The third national conference on the polar sciences, it was conducted very recently, and if you see the statistics, 8 themes, 24 sub-themes, 8 keynote lectures, and all these seminars, not by individual researchers were there, but there were also some dignitaries, practically the Deputy Advisor, Deputy National Security Advisor, the Secretary Ministry of External Affairs, our own Secretary from Minister for Sciences, Dr. Shailesh Naik, all the dignitaries, they came and they delivered policy lectures that what science can deliver in Antarctic, apart from the key scientific issues which ran in some 20 or 24 themes. These are some of the features of that. This was third in the series. Outreach is one of the basic programs because we have to communicate what India is doing in the scientific field to the entire world community. And we have got a virtual conferences between Goa and the station, colleges and Bharti station, because the internet services are presently linked to Bharti station. Bharti has got some problem, but Bharti, we are directly in touch, and all these seminars are also sometimes held in Bharti, and they are televised widely. Then our own scientists have also published some of the non-scientific themes for general public. For example, you can see this book by Dr. Harsh Gupta. As I covered our scientific expedition to South Pole. There was another book which covered by Dr. Mukherjee, both in Hindi and English, another Hindi book. And then like this, there are several books which have also come up in Bangla, in Kannada, and in several Indian languages. So that science is becoming, our science basically is becoming more popular with the school-going students. And now, when you ask for penguin, I think even a KG student, nursery student, they know what penguin is, and where will you find a penguin. And I think that's the major contribution of the Indian Antarctic science. Thank you, gentlemen, for your time.
Thank you very much, Rasik. It was a wonderful